As you can maybe see, this is a 6502 CPU. It's a DIP package, 40-pin DIP. That's the Rockwell logo, and it says 6502AP. Reckons it was made in Mexico, and the date seems to be 1901. So it's either the 19th week of 2001, which seems unlikely, or even more likely, the first week of 2019. I can't really see what that means. I bought this off eBay. It's come from China. It's definitely been used looking at the pins. And so what I'm doing in my project at the moment is making my own 6502 CPU. But I'm not making a little package like this because I haven't got the technology to do that kind of thing. I'm making a 6502 out of individual logic gates, so out of AND gates, NOT gates, counters, timers, etc., etc. So let me show you the progress that I've got so far. Here are some of the boards that I've made so far. Each one is a 10 centimeter by 10 centimeter PCB, and I've been working on these for a while now, and each one is one component in the 6502. So let's take a look at how the 6502 works. This is a diagram. This is kind of like a schematic diagram of the inside of a CPU, of the 6502 CPU, and the CPU is split into various different parts. So what I've done is I've sort of assigned onto one of these boards various different parts of this design. Well, boards 1 and 2 of the set of boards that I'm making are the control unit boards. So they deal with the instruction register and all the logic to do with decoding instructions, and actually some stuff to do with resetting as well, because there's a special procedure you have to go through when you reset the CPU. So all the other boards I've done as individual boards, but this one didn't fit onto a single board. So I've made it as two boards, and they connect together like this by a couple of IDC connectors at the top here. This board's got 4 ROMs on it, which contain all the what's called here random control logic. So basically the microcode. It's the instruction registers on this board. The microcode is decoded by this board, and this board is largely connections to other boards and a little bit of logic, a little bit of decoding logic, 4 to 16-way decoders, etc. But it's mainly connectors to other boards. So the point of this one then is that these two are the main control unit for the entire project. And unfortunately, I've only managed to get this far with them. The PCBs have only just arrived. I need to solder these up and get cracking on them. And then the project will really start working, because these are basically the brain behind the entire thing. So the control boards are boards 1 and 2. The third board is the registers board. That's right here. And this is for the X register, Y register, accumulator, and stack pointer. Accumulator, X, Y, and stack pointer. So this board is pretty much complete. I just need a few more of the 10 segment LEDs or whatever they are. I'm missing a chip there, which I need to find. But apart from that, the board's pretty much soldered up. This is version 1.1 of it. I made a version 1.0. It wasn't so good, so I've gone for 1.1. So that's board 3, the registers. That's pretty much ready for action. Board 4 is the program counter board. This one is absolutely totally complete. I've got all the chips in place. I've got everything soldered on. And that's the version 1.0 of that. Program counter was pretty simple, really. It's just a 16-bit counter and a few other bits and pieces. So that was pretty straightforward. It's all completed, and that one has been tested as well. You can see that where I need to connect 2 boards together, I've used these IDC connectors. So you get a ribbon cable plugs into those, and that will, because it's only the data bus going through the 8-way connectors, the other things like the address bus need to go through these 20-way or 10-way IDC connectors. So that's all functioning, tested, and it's absolutely fine. Board 5 is the flags board. This one's all done and completed. This is version 1.0 of it, and I have found a slight bug. I think what it was that the 0 flag, or one of the flags anyway, I've got it inverted, so it's off when it should be on when it should be off, which I can probably code my way around, although it'd be nice if it was the right way around. So I'm just missing a couple of connectors that need to be soldered in there, but apart from that, that's pretty much ready to go. Actually, it goes up this way, because here are the 4 LEDs for the negative flag, overflow flag, 0 flag, and carry flag. Now what I've done in this project is not implement some of the flags, like the decimal flag, because I'm not interested in binary coded decimal, and there's no interrupt flag because I haven't implemented interrupts on my 6502. Board 6 is the ALU, which lives down here, usually drawn in a kind of horseshoe shape in CPU diagrams. This was my ALU. This actually is my version 1.0 ALU. You can see I made that one in December, so that's been hanging around a while. It had a few problems with it. It did most of what it should be doing, but it had a few bugs. So I've built a version 1.1, which is here, that unfortunately I forgot to write the details on, so it doesn't actually say ALU 1.1. Okay, so memory address register then is the parts of the CPU that deal with things like, well, basically putting a 16-bit address onto the address bus so that you can talk to the memory. So this is the memory address register board. It's got a bit of complexity because it has to deal with different addressing modes. So pointing to memory from the program counter, pointing to memory from the memory address register, and also handling 0 page and page 1, which is the stack. When you use the stack pointer, you point to page 1. So that board is all sorted out. And lastly, board 8 is the RAM and ROM board. So although not strictly part of the CPU, this is the board where I put a ROM there with the program in, 64K RAM here, and a little bit of address decoding logic. So to summarise, I've got 8 boards in various stages of completion. I've got most of the components have now arrived, and all I need to do is get soldering, connect this thing up, and I should have a working project.